Thank you, everybody. Thank you for coming to our talk. We'll be discussing what's in a build system. We're talking about advancements in building Ceph. I'm John Mulligan. I'm a software developer at IBM. My main focus is on the SMB stack, and I contribute to orchestration. I'm a member of the Samba team. I'm a heavy user of Python, and I am just crazy about containers.
Hi, I'm Zach, also a software developer at IBM. I've been involved with the Ceph project since the ink tank days. I mostly focus on developer experience, primarily a Python developer. But in this project, I had to use a lot of Groovy, a fair amount of Bash, a little bit of Python, and a tiny bit of Rust.
So what we'll be talking about today is the existing or legacy build jobs. We'll talk about how we containerize the builds. We'll talk about new build pipelines. We'll talk about some of our future directions, and of course, we'll get to a conclusion at the end. So, the history of build in Ceph involved people saying many sorts of things. These are kind of derived from experiences we've had in conversations and things we've seen people say on Slack. Folks say, this shaman build failed. Well, shaman build, okay, I'm not sure what that is exactly. Shout out to Dan Mick, that's one of his pet peeves. How do I build this stuff on my laptop? Ceph seems to support Ubuntu, CentOS. I don't run either of those distributions. Suddenly MakeCheck just started failing. I don't know how to build these, I don't need these extra builds to do my Toothology job. All I need is x86 Ubuntu. And all sorts of different things. Source of a lot of frustration for folks. But before we move on and talk about how we've improved the build, we want to talk about what a build is in a more abstract way. In particular, what is a build for Ceph? From a build perspective, Ceph is a pretty large code base. It's made up of C++ as its primary language. It has a heavy dose of Python, a good amount of TypeScript, JavaScript, web front-endy stuff that I don't really understand. And it also has a sprinkling of things like Lua and Shell in there. Building Ceph is the process of transforming all this stuff into something usable. What something usable is varies from person to person. A developer might want just an OSD binary or the ability to run some unit tests. Consumers and higher level tests want packages or container images. This is a more visual representation of what I just discussed. We have source code as the most basic aspect of the build. On top of that, the source code is gathered into Git repos, most notably Ceph/Ceph. CMake is the primary driver of the build process, along with the build tool Ninja. And that's the thing that actually runs the compiler, that runs the various scripts that turn things into binaries. Particularly in Ceph, we have a large amount of build scripts, some of them in Ceph, Ceph/Ceph, as well as outside of it in like repos such as Ceph build. And then finally, we have sitting on top of all of that CI automation, primarily Jenkins, executing the scripts, executing the build process, and then out pops your containers, your Debian packages, your RPM packages. So to talk about the legacy build jobs, here's Zach.
So, as we all know, waiting for builds can be frustrating. And on top of that, our upstream builds have been unreliable and difficult to debug. Developers, if a build fails, have to ask for help and then wait for the help to arrive and then start over. After seeing that pattern over the years, I was eventually inspired to work to remove some of those sharp edges to try to make it easier to use. And here I'll outline some of the challenges we've had with the legacy jobs. First, they're confusing. There are actually 3 sets of them. They use a shared library that's written in Bash. It is a few thousand lines long. That isn't necessarily a problem. However, the way that that they're constructed in Jenkins. It's all concatenated together. So you have thousands of lines of bash preceding the actual jobs code, which is often far, far shorter than that. Additionally, the various functions in this shared library, they use global variables, and the functions set values as side effects, and so it's really hard to, you have to understand a large chunk of the code to be able to make any changes safely. And more than that, in terms of debugging, the parent builds don't link to the child builds, so traceability is difficult. That adds a lot of friction to the debug process. All of the logging output being in the same stream is kind of a similar thing, just adds more friction. And over time, the gaps between the builds we were doing in CI and therefore publishing and the builds that a developer would be doing on their laptop, that gap just widened over time. So you could not reproduce our CI builds locally. So they've also been inflexible in that we can't point to a specific commit to build, only a branch. Anytime you invoke a build, you're building all of our supported platforms, and you probably only want to test one of them. If your container stage failed for whatever reason, you had to start over from the beginning. And to test changes to these jobs, you had to duplicate them in Jenkins. This is a bit of a detail, but it's really hard to mix with the triggering, so it often ended up not getting done. And the old jobs were inefficient. We were building 3 different source tarballs, oftentimes twice because of the way the triggering worked. During the package builds, we use a tool called DWZ to deduplicate the debug info that's generated. DWZ is single-threaded, and so it takes a very long time. Initially, during some exploratory work for this project, I was using a machine that had 80 cores. So the single-threaded nature of DWZ really stood out. And also, there's no real cache. So the Ceph project technically does have Ccache built into a bunch of its build scripts, but on our build nodes, well, the cache isn't shared across them, and we have many of them. And since the paths are not normalized, there were no real cache hits to speak of. So not a very approachable system, right? Let's see a quick visual aid here. Up top, we have our 3 use cases. We've got our release builds, which are invoked manually. We've got our named branch builds, which are invoked on a set schedule. And we have our developer branch builds, which are invoked via a push to the Ceph CI repository. Now in the middle, we have our legacy jobs. These are the ones that are written in Bash that I was just talking about. Toward the end, we upload to Chakra and notify Shaman. So we've got duplication of code. We have a lot of complexity, some of which is unnecessary. And we have some unclear separation of concerns between the Ceph build repo and the Ceph repo itself. So there's some of the problems. We'll start to hear about some of the solutions from John.
Thank you very much. So one of the major aspects that we undertook to improve the process was to containerize the builds. Containers are generally about isolation and control. Isolation to separate what you're building from the platform it's running on, and poking intentional holes in that isolation so you can get in and out exactly what you want. Sorry. Yeah, so we're using OCI containers. OCI containers are like Podman and Docker. If you're a fan of LXC and you've used those in builds before, more power to you, but that's outside of the scope of what we were working on. We wanted to create a host-agnostic bundle so that we could have all the dependencies that we needed inside a single image to do the build. We wanted to encapsulate all the various build scripts, like installing the dependencies, running make check, things like that in a single unit. And one other interesting aspect of what we chose is to share the Ceph source tree with the host. I've seen other approaches to building in containers where the container does all the git pull, which is useful, especially when you're getting started, but it doesn't help as much when you want to iterate on small changes quickly. So I want to introduce the tool we developed, which is called Build with Container. I also want to give a shout out to Ernesto, who had started an effort to containerize make check many years ago. And someone pointed me at this PR, and that's what got me started on this journey. Took a while, but eventually evolved into this script. Build with Container, or BWC if you're talking to me or we're chatting over Slack. This tool implements the general interface between the build scripts and the container engine, so aforementioned Podman or Docker. It's designed to be usable by developers and in the CI system. It has a minimal set of dependencies, including the Ceph source tree, Python, and Docker or Podman. You have to use a somewhat recent version. We'll be vague about that. If you want more details, feel free to ask later. When you first use the tool to build anything, it will try to generate a unified build image, and it'll attempt to reuse that image as much as it can, unless it sees something has changed, like your source branch or a few of the important files used to generate the container. And then finally, we have help. I think it's a pretty decent -- help option, if I do say so myself. And we have a document within the Ceph source tree at containerbuild.md. So I want to quickly run through a few basic examples, just to show you how easy the tool is to use. First off, we're going to kick off a build on Ubuntu Jammy, or a Jammy-based image. And build in this aspect means just compile the binaries. The middle example is going to run the make check test suite on CentOS 9-based image. And the final example on this slide is going to build Debian packages on Ubuntu Noble. We're going to go into a few more complicated examples now. The first example here is going to use a Rocky Linux 10-based image. It's going to use something called an overlay directory. An overlay directory causes all writes to go into that location. If you're curious about that, please feel free to ask later. And then it's going to build RPMs. The middle example is the most complex example we have. This is going to use a CentOS 9-based container image. It's also going to use an overlay. We're going to manually invoke the configure step because custom commands do not know that configure is required. And then we're going to issue a custom command. Everything after the -- is a shell command that will be passed on to bash. In this case, we're going to be running the ctest tool in order to run a subtest of what make test runs and execute various Python-based tox tests that come with the Ceph manager. Finally, we can also create an interactive shell within the container image in case you want to jump in there and just mess around and experiment with things. And that basically covers build with container. Back to Zack for the build pipeline.
Thanks. So yeah, a bit about the new build pipelines now. These are Jenkins pipelines. They're written in Groovy, which would not have been my first choice, but it did force me to really understand that old bash code. So here are some of the improvements I was able to make with these new pipelines. First, they're easier to follow and debug. There are fewer of them. There is one set instead of 3. There's less unstructured code. Nothing is embedded into the job from elsewhere. We have clickable links in the Jenkins UI to the branch, the commit, the source distribution build, the shaman page, and I think some others. We split our logs into phases, so you can, for example, inspect just your Ubuntu Noble ARM64 Crimson build. You can isolate just the compile and package phase. You can also look at other parts like the builder image process, the Ceph container build itself, the upload to Chakra, and so on. They're also more flexible. You can build specific commits now. You can control exactly which OS architecture and flavor combinations that you want to build. And the jobs can build on any host with a recent podman, so they don't have to compete nearly as much with each other for access to our scarce resources. It's also very easy to test changes to the new pipelines. the build job takes a branch of the Ceph build repo as a parameter, so we can run as many different experiments as we want concurrently without breaking anyone else's builds. They're also more efficient in that we're only building one source tarball at this point. We skip DWZ by default because it's kind of mostly not worth it for almost every use case. You can enable it though if you want to for your particular builds. And by default, we use a shared compiler cache. You can disable that if you want, and more on that in just a minute. First, I want to show you another diagram. I made this to really just illustrate how the new system has less moving parts. The pipe-shaped items in the middle are the new pipelines. Everything else is pretty much the same. So we have Ceph source dist that creates the source distribution, the tarball, and Ceph dev pipeline is responsible for nearly everything else. It makes the builder container. I should have mentioned this more explicitly. We use build with container here. We couldn't have really done a lot of this without it. So Ceph dev pipeline is responsible for the builder container, the compilation, the packaging, the Ceph container itself, and uploading all of the artifacts. And Ceph release pipeline off to the side there was written by David Galloway. It wraps Ceph source dist and Ceph dev pipeline. So even our releases aren't nearly as special as we thought that they had to be. So I mentioned earlier that triggered builds were inflexible. In Jenkins, an admin could manually trigger the legacy jobs and tweak what was built, but now we're able to give everyone that level of control. With Ceph trigger build, this works with Git trailers. Git trailers go in your commit message, like in the example here. And in fact, you're already using them. Signed off by is a Git trailer. This example commit message would trigger a build on both CentOS 9 and Ubuntu Noble, just on the ARM64 architecture. It would use the Crimson debug flavor, and it would skip the Ceph container build phase. We do have a document linked at the bottom here that does detail all the other various options. One quick word of caution with the Git trailers is that you have to use dashes on the left-hand side, the key portion you see here, kind of like signed off by, we're all used to seeing that. Underscores don't get parsed properly. This is a Git thing, just something to keep in mind. So I promised a bit about the cache here. We're using a tool called SC Cache. This is a Mozilla project. I mentioned Rust earlier. They wrote it in Rust. I had some patches for it. It's basically, well, part of it is Ccache with cloud storage. It supports a number of cloud storage backends, and it lets us share the cache across all of our build machines. It also supports distributed compilation. We're not currently using that. I did do some proof of concept work with it though, and it's pretty nice. So our shared cache is hosted in IBM Cloud. It's using the object store. It's using object storage via SC Cache's S3 backend. Currently, it's only usable by the Jenkins builders that we have. And the size of it is about 8 terabytes, although I will say I had to update that quota multiple times during the development of this talk. We're still figuring out how big our cache needs to be. So I want to say a tiny bit about performance here. I promised some improvements. We'll see some specifics here. A fairly simple chart. This chart represents some jammy builds on one of our faster build machines. If a basic compile and package stage took about an hour before, if we disabled DWZ and changed nothing else, we drop to just over a half an hour. If we then enable the cache and don't really change anything else, in this example, it's a 9% hit rate. Nothing really changes. But with a fully warm cache, we're down to about 20 minutes. Now, in the real world, we'll see figures between, in the range of those last two. But I think the benefit is pretty obvious. So there is still room for improvement. I think that we will in the future be able to provide at least read-only public cache, which can help developers on their laptops do builds a lot faster. They will have to be using the build with container tool to benefit from this. I would like to see us support distributed compilation, potentially. This would have to wait for our new lab, so the end of this year, early next year. But in a test setup that I had during that initial POC work that I mentioned, I had a 3-node cluster and warm cache builds completing in 6 minutes. So I think this is something worth pursuing. I would also like to see us cancel builds when, say you push 2 commits to your feature branch, separated by a few minutes. We've always kept the original build going. I don't think we need to do that. If we start canceling these, older builds on the superseding push events, I think we could save a lot more resource. So now here's the part you get to participate in. What's next? I say use the new pipeline. And in fact, if you're doing pushes to Ceph CI, you are today. But a thing that you can do is learn how to use the Jenkins pipeline overview to look at the different stages and view logs to see what's happening. Mostly this is useful when things go wrong, of course. And it's also obviously really useful to learn how to use these Git trailers to control what's getting built. You may not have to wait nearly as long to do your truthology tests in the future. John?
Thanks. So from a BWC point of view, I'd love it if more people were trying it out, giving it a whirl. I think one of the great use cases for it is to be able to develop for future platforms. We can add distros as they come online, say the next Ubuntu LTS next spring, and start working on it far before we need to have everything glued together in the CI. In addition, you can use it to replicate CI failures on your own machine and get more into the guts of it than you would if you were running it on the CI. And then, of course, if you do use it, please feel free to report issues. Slack's a great place, or you can find a place in the tracker to talk to us. For general complaints about build, whether it's BWC or the CI, Sepia channel on Ceph Slack is a traditional place. So that's a good resource to keep using. And then finally, if you want to get involved in making the build better overall, we have a fairly new channel, Ceph Build Sig, where we discuss all sorts of aspects of the build process. We also do meet on Wednesdays on a US-friendly time zone, so if it's convenient for you, you can also consider joining there. And with that, we have reached the end of our presentation. Thank you, and do you have any questions?
I'm not sure if it's a question or comment
Comment's
or request for. I've used the build with containers. It seems to be geared to a specific scenario that you had in mind for the development work, which doesn't fit what I need to do for me. So I managed a few months ago to get things right. I'm not touching that container. It's there. I don't know what I'll do if it dies, because it took me so many times to get all the parameters right. Now, I think we should discuss the details in some other form, but basically, it seems that you treat what is done there in this script as building running, and that's it. Usually what I'm doing if I'm asked to solve a problem in some far-gone version is build, maintain, preferably maintain the source on the host, and then work for a few weeks on the same place. Interact with Git, which requires permissions, requires all the tokens that are required to work with Git, required me to be able to run, which requires rooted containers for some of the tests that we are running, and all of this had to be patched into the. Now I'm not sure, and you should decide if it should be a different script or just adding many more options to build with containers.
Yeah, So I highly encourage you to join the channel if you can. Write down what you're doing, share a draft PR, whatever's convenient for you, and let's start having that conversation. Off the top of my head, it feels like you need a more, like a persistent version of interactive mode, and we can talk about how we could build something
exactly.
like that.
That's
Thank you.
For what it's worth, I've been using it, and it's awesome.
Thank you.
I used to have a really janky thing I did to generate a spec file, and then to get a, whatever, it was a pain. Build container is way better. I have a script that I then take that, add some stuff to add my user into it, and then just bind mount my home directory. That would be a cool mode.
Thank you. Good idea.
Hi. We've developed our own kind of offloaded containerized build system for the FastDC development. We borrow some time on a nice powerful server with lots of memory, and we use it kind of like your interactive mode and kind of like Ronin with long-term running. And I even run an IDE kind of with remote access in that container. And mainly what I'm saying is we have trouble maintaining it, and we haven't updated the container image in about a year. So anything we can do to work together and improve both those systems, I'll be very interested in. So I'll join those channels.
And for what it's worth, you can ask it, this wasn't in my examples, but you can ask it just to spit out the build image and then do whatever you want with that image afterward. Yes. Sam mentioned that the other day. He's doing that, so.
Cool. Yeah, I'll join the Slack channel, ask more detailed questions when it's not about to be dinner. So. Cool, thank you.
Hello. I've been before in the talk, I think, from Joao about the what's it called, the CBS build tools, classes. Like, what's the difference between the tools you are working on and this build container tool that John and Zach are working on? And like, it seems like different tools for the same goal, so why not joining efforts to try to have something which is like easier for the developers to build, distribute, and like,
Yeah, I will say I think we do have an opportunity to converge some of our work. I think that what Joao has been working on is, it sounds really similar to what we've been doing, but there are some pretty important differences. Like, I mean, for one, I think the support matrix is very different for CLISO versus Ceph upstream, right? And I think Joao has some really interesting ideas around the way he's mapped container files into YAML files to make them more composable. I think that's an idea that we could bring over to this side. I think that can make a lot of sense. But I think a big piece is that we weren't completely aware of each other's work. So I think that we were solving different issues, and I think we've each done a good job at solving the problems that we set out to solve. But if we can converge to reduce any duplication of effort, I'd be excited to do that.
yeah.
I'm curious, quick show of hands, who builds in containers, whether it's with this script or not? Cool. So feel free to shoot us thoughts and reactions.
I have another question, maybe not sure if
Get
it
off
is
the stage! Wait, I'm on the stage.
not sure if it is related or not, but is there some progress like running tautology locally? Because I would like to have something to run some end-to-end test, if possible, on my local machine and get the results in some reasonable time without needing to wait like 1 or 2 weeks for the long tutorial runs to get the feedback. That's slows down our development process really like a lot.
So you and I should chat. I have a totally separate tool that I made a while ago. It's called Ceph DevStack, and what it does is it will stand up a micro Sepia lab on, for example, a laptop using rootless Podman containers, it starts up the paddles database, it starts up a Toothology container, it starts up containerized test nodes, and it can run some limited Ceph tests with fake loop device storage. You can also plumb in actual storage on a real machine, and you can also point that same tool at external test nodes if you need that level of performance and real hardware. So it's very flexible, and I think it could really help you out potentially, so we should talk.
And on top of that, I've also experimented with pulling out some of those dependencies. I have that PR. So anyway, it's something we're both interested in and we'll be definitely looking more into in the future.
Hello. Well, first of all, congratulations for this. As John mentioned, I tried that a while ago, and yeah, I wasn't successful. But I was curious about security, right? When I tried that, I remember I went for I think it was initially rootful container, and then I tried to switch to a rootless. Have you managed to do that?
Yeah, when you're running Podman in the CI stack, it's all rootless. If you're running Podman on your desktop, by default, it's rootless. I think you'd have to jump through hoops to make it rootful if you want to. The orcs are angry.
Okay. Yeah. So one last comment on that. Is it possible to run all the C tests inside that? Because I remember with the RBD test, I was having issues with yeah? Okay, so it's really intense there. No, I was asking about the rootless mode and the CMake tests, right? I remember I had issues running that in RBD test or something because they require some, access to, I don't remember, ulimits or some specific thing.
Is this a sign to get off the stage?
So can we run a full make check?
You should be able to.
In rootless, right?
There's like one thing it tries to do with like sysctl stuff, but we just skip it. It's not necessary. It's just like tries to help the CI. What was the thing we did with the ulimit stuff?
For build with container?
Yeah.
I can't remember off the top of my head. I will say I've mentioned this Ceph dev stack utility before. I've run into basically every issue with rootless Podman containers that you can with this. So it's something that I've at least dealt with there if we haven't in build with container. Like I wrote an SE Linux policy for that tool. And it lets you do sysctl inside the container. So if we need to enable that, we can do that too.
MakeCheck itself doesn't really have a lot of needs, but it's intense. It does a bunch of really stressful things to the system. So if you tune things externally to the container, it's generally fine.
Thank you.
Yes, I have run MakeCheck on my desktop, and it really heats up the room.
So really great work, by the way. I just had a question about the logs for the new pipeline. So can you just explain more about how, and I'll look into it, of course, but how does it differ from the old process of looking through the logs? I know it's you can zoom in, but yeah.
Yeah, so this would be easier if I had a demo prepared or something, but this involves poking around in the Jenkins UI. And so what lets us view the different stages of the logs is you actually have to avoid what the console log option there, because that was made before the pipelines were built into Jenkins. So that still shows everything combined, which, trust me, you don't want. So there is, in Jenkins world, everything is implemented in plugins. So there's this plugin called the Pipeline Overview, and that has a separate UI where it has a sort of sidebar where it'll show all the different phases. It pretty much has the whole matrix exploded, so all the different, CentOS, Rocky, Ubuntu, and so on. And each one of those has a sub menu. And so each of the different, I tried to logically construct these pipelines for this view so that and they're even labeled like you've got build container, and then inside that you have the different sub-stages of the builder container, and then the build itself has the different, preparatory commands split out from the rest. So it's hard to explain verbally, but when you've seen it, and I can show it to you, it's pretty easy to understand for the most part.
Awesome. Thanks so much.
Is there any plan to move to CIS code as Jenkins pipelines or something like that, so we can have that version? Because I remember that with Ceph build, it's always an issue, right? When you make any changes, they might affect older versions of Ceph. So are there any plans to have or move part of the Ceph build stuff to
move it where?
to Ceph as Jenkins files or Jenkins pipelines?
Oh, so you mean keeping all of the
Yeah.
logic in the Ceph repo? This is something that I think I may have even initially proposed. I would not be opposed to it at all. I think one of the bottlenecks there is, as part of the process of Jenkins starting up a pipeline on a builder node, as opposed to the little beginning bits that happen on the main Jenkins server, it has to check out the specified repository, and for Ceph, that's a lot. And so sometimes it kind of comes down to just this logistical issue of, do you want each of your builds to have to do a 1 gigabyte Git clone before they even know what they're doing? And the answer for us has been no in the past. But if it turns out that the better thing is to move it into the Ceph repo, that would simplify some things for sure.
Okay, thank you.
Yeah. All right. Well, thank you so much, everybody.